Now let's attach your Twist-O-Matic to a support beam. Ruler. Put the end of the rubber band in the middle of the ruler, like this. Clipper. Put the binder clip over it. Make sure the rubber band is still in the middle after you clip it. Repeat these steps with the other Twist-O-Matic. They should look like this when you're done. And here's a tip. If your ruler is a wavy shape like this, look for a flat part in the middle where you could place the rubber band.
If you don't have a ruler, you can use something else that is long, or you can just use the edge of a table. You also do not have an extra binder clip, so if you would like, you can use a piece of tape or something else that will hold the Twist-O-Matic up, and you will see in the next step how we are holding it up.
The Twist-O-Matics need to hang in the air to spin. So, ruler. Place one of the rulers on the edge of a table like this, so that the ride hangs in the air. Let about half the ruler hang off the table. Clipper. Put a heavy book on top so that it stays in place. Then repeat this for the other Twist-O-Matic. You'll want to put these right next to each other.
So you can see here with the ruler that you can just put it on the edge of the table. You don't have to have it hanging off. You can just put the rubber band right here and then put something heavy on top of it so it can hang off the table. And then you'll have to do your twisting one at a time.
For your rider's safety, check that both of your Twist-O-Matic rides are balanced. If they lean to one side, you may need to adjust the rubber band and clip like this, so that they're clipped on the center lines. Okay, before you start testing, let's talk about the difference between a turn and a spin. For a turn, start with the riders facing you. Turn it clockwise until you see them again. That's one turn. Now, a spin, release the ride after winding it up, and watch for the riders to pass in front of you. Every time you see the riders, that's one spin. If the ride's going really fast, just watch for the color of their outfits. If it only goes around halfway, that does not count as a spin. Okay, so now that you know this, go to the next step. Get your Twist-O-Matic challenge sheet. Each person needs one worksheet.
This is inside your yellow folder. Find your Twist-O-Matic challenge sheet.
For your first challenge, the engineer from Acme Amusements tells you that the Twist-O-Matic must spin exactly 5 times on its own. Work with your partner. Fill in your answers for challenge number 1 on your worksheet.
Okay, so right now you're going to need to pause the video and complete challenge number 1.
The supply manager for Acme Amusements comes to you with some bad news. It turns out that the thick rubber bands cost a lot of money. So the Twist-O-Matic ride cannot use thick rubber bands. Work with your partner. Fill in your answers for challenge number 2 on your worksheet.
Okay, so you're going to want to pause the video and complete challenge number 2. When you are done, go ahead and unpause the video to see what happens next.
Challenge 3. How will you make your real ride go? Where will the stored energy come from? Draw your ideas.
So here you're going to draw what you would think your new ride would look like in your ideas. Make sure that you use lots of details. You will need to pause the video, draw your ideas, and then go ahead and play the video to find out what you need to do next.
Discuss some ideas for challenge number 3. Then put your Twist-O-Matics away and watch the final video.
Okay, so once you are done, you can go ahead and keep listening.
The Twist-O-Matic might not seem like any kind of ride in real life, especially not one made from rubber bands, but there are actually amusement park rides that make use of elastic bands, like this, called the Slingshot Ride. And even though there's no spinning involved, what's happening in terms of energy is very similar. When you either pull back on a rubber band or when you twist a rubber band, like you did in the activity, the energy from your body gets stored in the rubber band. Or to be more exact, the energy from your arm muscles is getting stored in the rubber band. That's energy that came from the food you ate. When the rubber band is released, the stored energy gets released too, which is why your Twist-O-Matic would spin. But why did the thick rubber band spin faster than the thin rubber band, even though you gave them the same number of turns? We're hoping you noticed that the thick rubber band was a little harder to turn. Because you had to use more energy to turn it, that means more energy got stored in that rubber band. Which is also why, when you released the rides, the thick rubber band spun around a lot faster compared to the thin rubber band. In other words, the more energy you put in, the more energy you get out. The more energy stored in something, the more energy it can release. If you did want the thin rubber band to go as fast as the thick one, then you had to store more energy in the thin one by turning it around more times. Again, because you added more energy, it released more energy. It spun around faster. Notice how there's a connection between energy and speed. The more energy you store in something, the faster it goes when that energy is released. Or to put it another way, if you want something to go really fast, you're going to need a lot of energy. And that makes sense with other things you've probably noticed before. For example, the faster a car goes, the more gasoline it uses. The faster an Olympic athlete wants to move, the more food they need to eat. What if we had used an even thicker rubber band in the Twist-O-Matic? Not one this thick, but one more like this. Well, let's have a look. Let's spin it up. It takes a lot of effort to spin this one. Whoa, you see this? Look at how much that thick one spins. If you liked using rubber bands as a way of exploring the connection between energy and speed, definitely check out some of the other activities you can try, which we've linked in the optional extras. Have fun and stay curious.